Welcome to Networks Professionals.
Hey everyone, and welcome to this explainer. I am genuinely so thrilled you're joining us today because we are tackling one of the absolute most foundational, yet honestly fascinating concepts in networking. I want you to imagine just for a second a sprawling, super busy city. You've got millions of cars trying to get from point A to point B. Now picture the network administrator not just sitting back and watching the traffic, but acting as the ultimate city planner and the chief traffic cop all rolled into one. They are literally the ones standing right there at the intersections, manually drawing out the maps and pointing every single car down the exact street it needs to take. No detours, no guesswork. That incredible level of precision is exactly what we're going to unpack today as we demystify static routing and really explore the manual art of network control.
Okay, let's dive right into our roadmap for this session. We'll start with a quick introduction to static routing, then look at its key characteristics. After that, we'll break down the 5 core parameters, jump into a real Cisco configuration example, and finish up by weighing static against dynamic routing.
All right, part 1, Introduction to Static Routing.
Think for a moment about the total chaos of unguided network traffic. We're talking data packets just hopelessly bouncing around with zero sense of direction. It would be a complete disaster, right? Well, to prevent that, static routing steps in to offer absolute deliberate control. By definition, it's a method where network administrators manually program the exact paths that data packets have to take to travel between different network segments. Now, the operative word here is definitely manually. Unlike dynamic routing protocols, the ones that talk to each other and figure things out on the fly, these static routes absolutely do not update automatically. So if your network topology changes, say you add a new department or even just move a router, you, the administrator, have to go right back in and manually reconfigure those paths. It's hands-on networking in its purest, most fundamental form.
Moving on to Section 2, Key Route Characteristics.
Now, you might be wondering, if it requires so much manual effort, why on earth would an administrator actually choose to wield this level of control? Well, the crucial point is understanding the trade-offs. First off, static routing is incredibly predictable and highly secure. Because you are completely hard-coding the routes, the traffic follows exact, predetermined paths. There are absolutely no surprises here. Second, it is massively resource efficient. Since there are no complex routing algorithms or calculations running in the background constantly, it consumes minimal bandwidth and CPU power. Your hardware barely even has to break a sweat. But, and this is a huge catch, there is no automatic failover. If a physical link goes down, your traffic drops instantly. It literally just stops. That is, of course, unless you've manually added a redundant backup, what we call a floating static route. So as you can see, the stakes are definitely high.
All right, Section 3, the 5 core parameters.
Okay, so we've got the concept down. Now let's talk about the actual mechanics. These are the literal building blocks that our city planner uses to map the network. I actually want to slow down our pacing just a bit here so we can really walk through the router's checklist. To establish a static route, administrators have to input 5 core parameters. Number 1 is the destination network. This is the IP address of the remote network you ultimately want to reach. Number 2 is the subnet mask, which has to perfectly correspond to that destination network. Number 3 is the next hop. Think of this kind of like passing a baton in a relay race. It's the IP address of the neighboring router that's going to forward the packet one step closer to its destination. Number 4 is the outbound interface, meaning the physical local router port where the traffic should actually exit. And number 5, which is exceptionally important, is the administrative distance. This is effectively a trust rating for the route. Because static routes are manually configured by a human administrator, they are highly trusted by the device. Therefore, they're typically assigned an administrative distance of 1. It's basically the router's way of saying, hey, the boss put this here, so I trust it above everything else.
Let's see this in action with Section 4, a Cisco configuration example. This is where we pivot from abstract networking concepts to the physical reality of the command line. This is where the magic actually happens. What's really interesting here is just the sheer elegance of the syntax on a Cisco iOS device. When you're in global configuration mode, you can tell by that config in parentheses, establishing the path is as straightforward as typing the IP route command and then just following it up with our parameters, the destination network, the subnet mask, and that next hop IP. It is beautifully simple, but incredibly powerful.
Let's walk through a real-world application of this exact command. Let's say your local router, we'll go ahead and call it router A, is connected to network 1. But it urgently needs to send traffic over to network 2, which happens to have an IP of 10.0.0.0. To get there, the packet needs to be passed to the next hop router located at 172.16.0.2. So what do? You would simply input IP route 10.0.0.0, 255.255.255.0, 172.16.0.2. Boom. You have just successfully mapped the city. You've told the traffic exactly where to go and exactly who to hand the packet to next.
And finally, Section 5, Static versus Dynamic Routing. We are officially entering the final showdown, placing our manual static routing approach directly head-to-head against automatic dynamic routing protocols like OSPF or EIGRP. This comparison brilliantly illustrates the core tension in network design. When we talk about network size, static routing is best for small, simple, or what we call stub networks, whereas dynamic routing is the go-to for large, complex enterprise networks. Looking at maintenance, static requires high manual effort. Remember, you've got to update it yourself if anything at all changes. Dynamic, on the other hand, is incredibly low maintenance because it automatically updates. But then, consider security. Static routing gives you incredibly high control because administrators dictate the exact traffic flows. Dynamic routing offers a bit lower control because routes are just learned and calculated dynamically on the fly. It is literally a constant tug of war between high-maintenance precision on one side and highly scalable automation on the other.
So I want to leave you with this final, somewhat provocative thought. Which routing method does your network architecture truly need? Do you require the unyielding precision and absolute security of the manual art, or does your scale absolutely demand dynamic automation? I highly encourage you to take a look at the complexity of your own networks. And to further your mastery, definitely go explore the in-depth implementation guides like the Cisco Static Route Configuration Guide or the Huawei Static Routing example, which we referenced in our source material today. Thank you so much for joining me on this explainer, and keep learning.
Thanks for watching.